Okay, so we have a test coming tomorrow, and this test has lots of little topics on it. I don't feel like it's incredibly hard. The last test I felt like was pretty hard, especially that cumulative test covered so many things. But this test is doable, but let's do some practice. So grab your iPad, get to some virtual paper. Let's do a couple practice problems together to start the hour. You're going to have a fair amount of time to work on your review packet, which I have. It's on paper. It's right here. So first up, though, let's try one of these. If I needed the vertex form, which by the way would look like this, if I needed that vertex form, but I'm not given the vertex form, I'm given this form, I'd like you to first multiply this puppy out and then put it into vertex form. That's called completing the square. The vertex CTS. Because if you want the vertex, you got to complete the square. That's that deal where you move the number over and do half and square. All right, so give it a shot. First, you better multiply that thing out, though. I'm going to pause for a second while you try that one. Now, just a FYI, the middle term is going to have a fraction in it. So I would recommend, instead of like when you have to do half of 15, which is going to kind of come up at some point, that you do half n squared, but you do half of 15, not as 7.5. But when you need to do half of 15, which you will later, I hope you do 15 halves like that. Okay, that's half of 15. And then half n squared means you're going to go like this, n squared. And in case you don't know, 15 squared is 225. 2 squared is 4. All right, it's just a little hint to get you through. It's kind of a tough one here. I'm going to pause for a second while you try that. Hold on. So we are going to first multiply this puppy out. X squared plus 15x plus 56. Are you with me so far? Next, we have to move the 56 over and do half n squared. So this 56 goes over here. And half n squared means I do half of 15, 15 halves, and then I square it. And if I have a positive one of those, I also have a negative one of those. Negative 15 halves squared. Now notice that negative can't get squared away, otherwise this would be positive and that would be positive, and they wouldn't cancel each other off like they're supposed to. So this negative is going to wait until we're done squaring it and then get applied. All right, so then this part right here factors. You should have had y equals x plus 15 halves quantity squared. Then this part right here, I'm going to do 15 squared is 225 over 2 squared is 4. That's negative. And I'm going to add that to 56. That's a bit of a pain. All right, but you're in Precalc. You're supposed to be able to handle a little bit of algebra. And actually, this is just numbers. It's not even algebra. This theoretically you could have done in 6th grade, maybe even 5th or 4th. All right, so anyway, the 56 could be made into fourths if you knew how to get a common denominator. What's a good denominator? Fourths. So I times this by 4 down here, and if I times that by 4, I got to times this by 4. All right, so 4 times 56, 4 times 50 is 200. 6 times 4 is 24, 224. This was negative 225 over 4 plus positive 220, what was that again? 224 over 4. Final answer is negative 1/4. Worked out pretty cool. X plus 15 halves squared minus 1/4. Did anybody get all the way to that final answer? All right, like 7 of you. All right, so that's a tough one, mostly just because of that last number and needing to be able to handle fractions. Okay, why would we want the vertex form? Sorry, because then we know the vertex. Okay, and the vertex of it is negative that, negative 15 halves, comma negative 1/4. Could I change that to 7.5? Yeah, but that would have been way more challenging with this in the squaring part. But it would have been legal. Yes? The calculator is only going to be allowed for one question tomorrow, and that's the regression question. Okay, you got to be able to do, to do a regression question, you have to have a calculator. So, all right. Otherwise, bottom line is no, you wouldn't have a calculator for that. You have to be able to multiply and add and those kinds of things. All right, we talked about one of the kinds. Here's another kind we've talked about a lot. If I give you a parabola, you should be able to tell me the equation for said parabola. That is at 4, 0. Let's say another point on it is 6, 3. I'd like you to figure out for me the equation of the parabola that would go through those. I'll pause for a second while you try that one. Okay, you should have started with, just to make sure you started right, y equals a x minus h squared plus k. If you didn't know that equation off the top of your head, not likely to be able to finish this deal. Okay, got to have that figured out. Mr. K, tell me what to do first. All right, we can put a 3 there, I agree. And that's the x you're talking about there. We're going to put a 6 in there, okay. And that's right there is the h, which is 4. Good, keep going. So that's the 0 of the vertex. That's 0. Okay, good. So then 3 equals a times 6 minus 4 is 2 squared plus 0, and I don't have to put plus 0. So then it's really a is 3/4. Raise your hand if you had that. Good. Now, do you get you're not done though? Because now I just have to rewrite this again. Y equals 3/4 x, and then I got to actually put in the vertex, which was 4, 0. Here's the most common mistake people would make. What did I do wrong? No, there's something wrong. Something wrong with my equation right here. It's kind of right, but it's wrong somehow, tragically. Yes? Minus 4, because remember how this and this are supposed to be opposites of each other? Minus 4, not plus 4. Very easy to forget that. Okay? Yes? Okay, putting a plus 0 on there is optional. Plus 0 really doesn't do anything, right? So I agree, I could leave it like that. Any other questions? Okay. Next topic, let's talk power functions. Okay, is this a power function or not? Y equals 1 over 3km. Is it a power function or not? I'll pause for a second. And the answer is yes, by the way. So don't just say, oh, it's not. Yes, it is. Try to figure out what the power is and what the constant is. And by the way, usually it'll tell you this, but k is considered a constant. And so is pi, and so is c. So I want to know the power and the constant of variation. How many of you are confident on this? All right, since only 2 people are confident, I'd pay good attention here. First step, you want to figure out what the variable is. That is not a variable. I said that's a constant. That means it's like a number, like 12. So that means it gets grouped in with all the other numbers. Like all of those are just numbers. And that m is the only thing that's a variable then. And then I need to rewrite it so the m is on top. So I'm going to write it as y equals 1 over 3k, because that's the constant, times the letter, which could be on top or even just next to it. But if I had it on the bottom and it was m, if I bring it up to the top like this, it's going to be m to the negative 1. Do you get how it was a 1 degree before, or a power of 1 before? And now that I bring it up, it's a power of negative 1? Do you get that? If it was a power of 1 on the bottom and I bring it to the top, it's going to be a power of m to the power of negative 1. All right. Now that it's written like this, I think anybody could have got this one. Now, what's the power? Negative 1. What's the constant of variation? 1 over 3k. COV. That's the power. Make sense? Let's do another one like that. See if you catch this. Y equals 3 pi x to the 4th all over 2. If it's a power function, tell me its power and its constant of variation. All right, it should be done already if you know what's going on. The power is that. Why didn't I have to rewrite it? Because it was already on the top. If the x had been down here, it's like x to the negative 6 or something, I'd have had to put it on the top and say x to the positive 6. But it wasn't down there, it was on top. So there's the power. And the constant of variation is all the other stuff. So the constant of variation is 3 pi over 2. Questions on that one? How many had that one right? Okay, good. One more then. Actually, let's make it f of x. No, let's make it f of p is equal to 4p squared k all over 3. I'd like to know what the constant of variation is, which is probably where everybody's going to make their mistake, and what the power is. All right, call on a random person with the die's help here. It is row 2, which is one of that row. Person 1. Go ahead. Do tell me. Which would you know? Constant of variation, yep. No, because that's not the constant. It's a very common mistake. How do you know what the constant is? I can tell that's the variable because look, you know how it's f of x? I can tell that p is the variable. And remember that k's are constants. Name another thing that's commonly a constant. Pi is commonly a constant. And one more letter that's commonly used as a constant. C is commonly used as a constant. Okay, so p is not the constant. So if that's the variable, then everything else must be the constant, which is all of that. So how do I write that? 4k over 3, very good. That's the COV. And what's the other thing then that we need? The power, which is what? Power is 2. That's that. Yes?
What an example do you give one that's not?
All right. Actually, I should use this. There we go. Why isn't it a power function? There's no variable. Okay. What if there is a variable? If there is a variable and there's only one variable, then it's a power function. The only question is, what is the power? So if I put the variable in here as x, and I'm making it obvious because it's a different color even, and I make it like to the negative 12th, you have to know enough to rearrange it and then tell me, oh yeah, that's really an x to the 12th on top, and so this is my constant of variation, and that's my power. Okay. All right. Let's talk about how you could make these into word problems, because that's going to make it more of a challenge. All right, so ready? Try to write this one out as a power function. Have you ever heard of the formula E equals mc squared? Okay. I'm going to say a formula like that. I'm going to say that that energy varies directly as related to the force. Because, do you remember how I said c is usually a constant? Well, it is. In the E equals mc squared, c is a constant. Do you know what it is? Speed of light. Yes. So you don't have to know the speed of light for this. But what I'm asking you is, can you write me the formula in terms of a power function of energy in terms of mass? Mass varies directly as the energy. I may have said that incorrectly the very first time I said it, but I think if you're understanding what function we're talking about, you should be getting this by now. All right. If energy varies directly proportional to the mass, then that means the mass is on the top. And then I just need a constant, right? What's the constant? You're so close. What's the formula? E equals mc squared. Okay, good. There's your constant. Is this a power function? Yeah. And what is the power? It's not 2. That's a common goof. It's a 1 because it's on the variable. See what I mean? So this is the constant. That is your variable. And that's your power. I'm going to read you another famous formula, except I'm going to say it in that weird way and see if you can write it. Yes? First? Okay, why isn't it 2 with power? Because that's just a constant. That's just a number being squared. It's only the thing on the variable that makes the power. Okay? That's not a variable. I know you're thinking it is. It's not a variable. That's just a number like 12. The 1 is the power because that's the power on the variable. The variable is m. C is the speed of light, which has never changed. It's just a number. It's not varying. Okay? So that's the variable. Since that's the variable, that has to be the power. All right, let's do one more like that. Another famous formula, see if you know this one. Force is directly proportional to mass. And there is a constant usually in this formula. The constant they usually use in this formula is what? Does anybody know this famous formula? A. Very good. So I'm going to say this one more time. Force varies directly in terms of the mass of the object, and the constant is A. It's a famous formula. Force, it varies directly, means there's no fraction involved. If it had varied indirectly, I'd have made a fraction and put the variable down here. But it was not indirectly. It was directly on the mass. And then I said there was a constant, and I told you what to even use for the constant. What should you use for the constant? A. You ever heard of F equals ma? It's a pretty famous formula. Maybe not to you, but it is. All right. So how is this a power function? Yes. And what is the constant? A is the constant of variation. If that's the COV, that makes that the variable, which makes the power what? 1. Okay. That's the power. All right. We'll do more of these when I hand this worksheet out in a moment. But I want to do one more example that is the inverse kind, for indirect variation. And this is important to understand. Do you get that if I have a certain amount of workers, that the hours it'll take to get my, let's say, a driveway shoveled? It's a huge driveway, right? If you have one worker, let's say it takes you 10 hours. Do you get that if I have 2 workers, it's going to actually take you less time? So the bigger number, the bigger that this gets, the smaller that this gets. See what I'm saying? 2 workers, say it takes a total of 5 hours to get the job done, right? Okay, how about if we had 6 workers? Well, this is a power function. Okay, let's just do one more easy one. Let's say we had 4 workers. I bet you can do this one in your head pretty easy. What's that? 2.5. Now, if you were allowed to use a calculator on this puppy, if you were, then you'd put it in the calculator, right? And since I just told you it's a power function, then you'd be able to know, oh, I can do a power regression. And you get the equation for it. Go ahead and do that real quick. Because remember, there's a question where you're going to have to use a calculator, and it'll be half of the new. I think it's correct. Think of it this way. 4 people working for 2.5 hours is a lot like 1 person working for 10 hours, isn't it? Isn't it in the same kind of ratio? See. Pause for a second. I'll show you how to put that in the calculator. So I'm going to put this into my calculator. I'm in the stat menu right here. Once I'm in stat, I go to edit, and I'm going to clear out my old data. Clear. Oh, I have to hit enter. And then I go over here, up into there, clear, enter. And then I got clean spots to put my data. 1, enter, 2, enter, 4, enter. And then I go over here, and this is 10. I'll move this up a smidge. 10, enter 5, enter 2.5. Okay, then we go to stat. Calculate. A power regression is actually, I'm going up to get there because it takes a long ways to get there. There it is, power reg. And I have L1 and L2. Now, if you have a different calculator, you'd have, without this operating system, you have to type in L1, comma, L2, comma, Y1. Don't forget the commas. That's the most common mistake there. I'm now going to put in Y1 is under vars, Y vars, enter, enter. Go down to calculate, enter. Cool. There's my power regression. Okay, well, what does that mean for an equation? That means Y equals 10 is A, right, times X to the B, which is -1. Does that look like a nice power equation? What is the power? -1. What is the constant of variation? 10. Okay, you get that? And it's in the context of a thing I think you can understand, that the more workers you have, the less hours you have. Now, is that direct variation or indirect variation? Indirect. Because basically, as you add more to it, it goes down. As this gets bigger, if it was direct variation, as this gets bigger, that would get bigger. Okay, but as this gets bigger over here, this side gets bigger, that side gets smaller. And here's another way to think of this. If I asked you for the equation just by hand on this one, I would have said something like, write me an equation for if our hours are going to be X, write me an equation for hours varying indirectly with the number of workers. X, the time it takes varying directly with the number of workers that we have. Do you get that I could have rewritten this as Y equals 10 over X? I would have had to tell you that my constant of variation was a 10. But do you get how 10 over X and X to the -10 are the same exact thing? 10 over X and 10 times X to the -1 are the exact same thing. So if I said Y equals 10 over X, do you get that as a power function? And I'd have to rewrite, put the X up on top. You know what I'm saying? And now I can say what the power is. What's the power? What's the constant of variation? All right. What if I don't tell you that constant of variation? They're going to say right in the directions what to use for the constant, but it's usually K. It could be C. All right. So if they said, usually what they say is, if they don't tell you the constant, use K. So then I would say, there. And I said it's varying indirectly, which means that if it's indirect, it goes on the bottom, or inversely. Let me make sure to see which way we usually say it, inversely or indirectly. Yeah, it's directly or indirectly, which indirectly is kind of like inversely proportional. All right, I want to do one of your worksheet problems with you right now that's like that one, because I think the rest of this assignment is easy. It's just those word problems that are going to stump you a little bit. So let's do one of those off this packet. I'm going to pause for a second. I'll hand those out. All right, turn your attention to problem number 12. So we just talked about, problem number 12 is the one we just talked about with time and workers and stuff. While it's still fresh in your mind, oh, there's 6 in those rows, isn't there? I thought there was 5. That makes sense then. Okay, so please, while it's fresh in your mind, look at number 12A. Can you write that formula? We just talked it through. 12A, please. Do not start at the beginning of the worksheet. Go to 12A. And then one last thought. In the directions, it says use K for the constant of variation if one is not given. Okay, number 12 says the time, T, to complete a job is inversely, that means you use a fraction, proportional, to the number of workers, W. Did you say time is inversely, got to have a fraction, proportional with the W on the bottom? Raise your hand if you had that part right. Good. And then if you're supposed to have a constant, it'd be great if they told you it was 10 hours different per person, but they didn't tell us a constant, so what are we supposed to put? Put a K right there. Now, that's the power function, but could you also write this power function as kW to the negative 1? Yes, because then you'd be able to tell me what is its power. Come on, what's power? Negative 1. And what's the constant? Okay. K is the constant. Negative 1 is the power. All right. Part B. Neglecting air resistance. So in other words, let's not worry about that. The distance that an object falls varies directly, no fraction, as the square of the time it has been falling. Try to write me an equation for that. Obviously, it involves D's and T's and maybe a K. The distance that an object falls varies directly as the square of the time it has been falling. All right, so first off, distance varies directly, no fraction. It's all on the top then, okay? To what? The square of the time. That's the most common mistake answer right there because it forgets one important thing. It doesn't have a constant. If it doesn't have a constant, what are you supposed to put? Okay. Get what I'm saying? If you don't put a K in there, you didn't tell what the constant was. In the real world, is this the equation, D equals T squared, for something that's falling? No. It needs a constant in there, and actually, specifically, it is negative 4.9 meters squared is the constant you'd use for gravity on Earth, but you're not going to know that, so you have to put a K in there. So if it doesn't have a constant, put a K. All right. Part C, the force between two electrical charges, so just think of it as F, is indirectly proportional to the square of the distance. Just call it D. So you obviously have F and you have D, and it said indirectly, so that should tell you something. Don't forget, if it doesn't tell you a constant, use K. I don't want to tell you all the answers here. All right, E even confused me a little bit, so I want to help you with E as an elephant. The interest earned on a given principal. Interest earned on a given principal, P, for a constant interest rate, R. Ooh, they said it was constant. That'll give you a hint that R is not the variable, right? Is directly proportional to time, T. All right. Interest the constant is R. Got to have an R in here. And what else do I have to have in there? P and a T. You actually recognize that formula? It's a classic formula. Now, do I need to put in a K? No, because we already have a constant. Which one was it? I think it said R was the constant. It's a constant rate R. So that's the constant. There must be something else constant. Well, you can actually make this problem either way. You can say that time is your variable and figure out how much money you'll have, or you can say how much money you're putting into this investment, and you already know the interest rate because that's a constant. So anyway, this could be a constant or a variable. We are not going to try to trick you on this. This is the right answer. I equals P times R times T. Just trying to say that it is possible that one of these other two is also a constant. We put in a certain amount of money, so that makes it a constant. All right, look at number 13. It asks you to put that in as a regression. What kind of regression? You should be thinking that through. It says quadratic right there in the problem, so make sure you remember how to do those. I think your hardest part is going to be problems 10, 11, and then the part we just did, problem 12. All right, make sure you're good at those little things like doing things in vertex form, like problem 8. If you can't handle vertex form like that, I should do one with you. I'm not going to do number 8 because then you wouldn't have anything to practice. Would you please find a spot on the back side at the bottom? You won't need much room on the regression. You're just going to be typing that in the calculator anyway. So in the back side of your worksheet at the bottom, let me help you with one last of this kind. Would you please try this one with me? This is a complete the square. They'll say find the vertex. And what you should think is that's the vertex CTS. Complete the square. That reminds you, oh, I got to complete the square to do this. See if you know how to handle that factoring this number out deal. That's what I'm afraid is going to goon some of you. All right, -2 comes out front. And then I have x squared minus 4x. I took taking a 2 out, and it's not only a 2, it's a -2. So that makes this -4x. Do you get that? Because that times that has to make that. Okay. And then this -2 does not participate. It just moves over. You remember that? Don't try to factor the 2 out of the 2. A lot of people do. You can't factor it out of everything. Only these first two numbers. Then we do half and square. Half the 4 is 2. 2 squared is 4. Plus 4 and a -4. Then the most common mistake. People forget that this -2 has to also get multiplied right there. Final answer. Y equals -2. X minus 2 squared. That makes +8 minus 2. 8 minus 2, +6. It's in vertex form now. There's a vertex. 2, -6. Notice it's not -2, 6. It's 2, 6. Any questions about that? Did you get lost at any point in there? Okay. And that's all I've got for you.